Oh, I forgot. I always forgot about the bit pen. I'm going to set it up. Qué horror. Okay. Okay. Well, everything seems to be just fine. I'm still bothered that and getting all of those updates, so-called updates, when I'm supposed to have this sudo apt update upgrade running. Spotify is going to get a new update. Oh, because of the color of my shirt. Yeah, the AI is not going to be too accurate with that one. Okay. Well, yesterday I was able to watch a little bit of the course I've been working on. Let me show you. Oh wait, before continuing, I forgot to actually share this. I still have some time before my activities on my consulting agency start. So I have like a little less than an hour. So let's get the best of it, okay? Okay, so let's yesterday, let me shut down some of those. There we go. So I've been watching this short course. There is a rip on this lecture. Ah, because I'm not signed in. Okay. I got to just clone this section here inside my repo, obviously. Oh yeah, because I have I just forgot. Okay, so I have a branch where everything is going on. And these are the two folders I've been working on. This is from my previous course, and this is for my current course. I have uncommitted changes. So maybe I may like to fix that one from yesterday. So what are the changes? Okay, I basically add, let's make this a little bigger. I basically just add, there we go. That's as far as I can go. I imported the mark on this file on test environment. And basically I was testing out xfail and skip on this file. So that's what I'm going to do. That's what I'm going to put here. Okay, let's copy the name of the file. And now and that's it. I just add a mark import to not just well, I just add import. Let's put double quotes. The mark model to test xfail and escape, because I am testing escape too. I added escape here. There we go. Yeah, sure, why not? Yeah, I think it's really important to write good commit messages, because right now it's going to be easy for me to just because I have it more or less fresh in my mind. But after time passes, it's going to become harder and harder to figure it out what this particular commit was about. So a good message combined with the fact that you can open the commit and see the difference itself on Visual Studio Code, that's going to help me a lot to get the context right away. Well, I don't know what this is, but what I'm going to do, okay, this is my test. So what I'm going to do right now, I'm going to encapsulate all of this into its own folder. First test. Well, I can use spaces here. First test example. And I wonder if I'm going to be able to just move all of this down here. And there we go. Wait, what? Oh, no, yeah, it's okay. It's fine. First text example. Oh, the folder is outside, never mind. There we go. I found a little bit hard to read this. Let me see here. First text example. Okay, everything is down there. Never mind. Okay, so I did that because I want to encapsulate this folder, because I'm going to create another folder down here. So I am on the root folder for this course, because I am about to clone something. I'm about to git clone this guy's example, I think. What? Oh no, I replaced the copy. Never mind. There we go. And now I'm getting the elegant works folder there. So yeah, if I open this, there we go. So there are two things over here. There is only a README file. Okay, I need to go to the restroom real quick. I'll be right back. El café. The coffee is taking a punch on my gut right now. Be right back. Okay. Let's see. I still have like half an hour. Okay, so fine. It's detecting everything now. Let me see. Maybe a couple, or I might just add everything, you know. Wait, no, I know how. So do that first. There we go. I can do that. There we go. Now all of that is here. Moves. Yeah, it's not very clear, but I guess when I see this in the future, it's going to make sense. Wait, what? Oh, never mind. I think I messed up here, but who cares? It's going to be a squash anyway. Yeah. Well, the thing is, my plan here is to have two folders. The first test sample is basically the code from the exercises from the previous chapters of the course. So basically from chapters 2 and 3, maybe chapter 3 mainly, it's just 3. And writing grade tests will be this new folder over here. Where is it? Elegant frameworks. So that's I don't see anything, just one file over here. I don't think that's right. I don't think so. Oh wait, I didn't. I think I didn't copy the entire thing. Yeah, I'm going to need to delete that. Let's do it from here. Yeah, move to trash. And now, there we go. Okay, I am on the root folder for the course. Let's clone again. This should clone the entire. No, I didn't do shit. It's not cloning everything. Why not? It's just giving me. That's the only thing that is here actually. There is another link. Sample code for this exercise. Okay, let's try this. Yeah, I thought it was really weird that we are getting two links for the same exercise. So I guess maybe the first one is not working right, and the second one is the good one. No, it's just the same thing. Oh well, that's weird. Well, I have several branches. No, those are stale. This is the newest one. Okay. Maybe this is what I'm looking for. Or maybe I should just let's give it a last try. If you're wondering why I'm not pushing down the shortcut, it's because I'm using a wireless Logitech keyboard right now. And the thing is that with this keyboard, I don't really have the insert key. I don't see it. Oh, there it is. There is the insert key. Many keys are not really available right now, so I need to push the function key and then another key in order to get the insert key. So it becomes very cumbersome when I'm trying to use like a control insert in order to copy something on the terminal. So I think it's way easier to just use the mouse. Oh wait. Okay. Let's try again. Git clone. Let's try it that way anyway. Okay. Chef fn insert. There we go. It's going to do the same thing. Okay, let's clone it. Okay, the clone is ready. There is just one thing. Git branch. Oh, but because I guess the most sensible thing to do would be to just download the zip files and call it a day. There we go. The mouse died. Okay. Where is it? I just downloaded it. Okay, I have the files now. Wow. This is taking way too long. And for some reason, I'm getting like the first version of the code repo. I don't know why. Okay. There we go. So I guess I'm going to delete this one. I'm going to add this. There we go. What section is this? Well, I guess I can close this. And are you done? Okay. Okay. So you are section 4. Writing great tests. It's for section 4. There we go. Okay, so let's take a good read of the code, shall we? Here we are. So there is the README, totally useless right now because it doesn't really contain any valuable information. And here we are, the setup. From setup tools, import setup. That's new. Find packages. Elegant casing. Okay. I didn't show that on this video. Maybe later. Title case. This guy had its own. Oh, okay. It's going to import. Title case is going to import its own Python file down there. This one here. And that's all. It's basically, I guess this one is going to initialize the model for this folder. And the test, we have a Pytest that he's using, and the test title case. Okay, so far so good. This should be capitalized. This should be capitalized. Okay. Return the text. No more coffee. And he's just asserting. I think this is just the regular Python assert, which means that whatever I learned of assert true as a function, I think this comes from unit test library indeed. I guess regular Python has its own assert keyword here. He's just asserting that. And that's the test. No, don't save. Did I change anything? I don't think so. Pytest ini. Okay, I already saw that. This is for the test. The title case. I think it's not going to work if I try to run the test right there. Yeah, that's it. Yeah, I need to install packages, and I'm not even. I wonder where is the environment. Do you have the environment here? No. The VM is here. Maybe I need to move that. Well, you know what? I'm just going to finish watching this. Do I have time? Yeah, sometime. I'm going to shut up and just listen.
Okay, so today I just want to go over very quickly something that I mentioned in the last lecture about unit testing. And that is, it was kind of annoying when we had to keep uninstalling or reinstalling this directory every time we made a change, so that when we ran our tests, it would pick up the latest version. And I said we had to do that. Why? I said we had to do it because our test directory should be in the same directory, the same root directory as our library. And when that happens, I can't just, the tests don't have access to this. I can't just import it without messing with the path. And messing with the path is almost always a bad idea, unless you really know what you're doing. So what did we do last time? We just kept pip installing this directory and pip uninstalling it, and that was annoying. That's not a good way to move forward. I just didn't want to get into the details before we understood what we were doing in terms of the unit tests. Now I'm going to go ahead and get you the rest of the way. I'm going to do it as quickly and clearly as possible. So basically, we're going to talk about talks. I mentioned in the last one very briefly. What is talks? Well, and I will link you to the same page in this video. But we're going to go over just the most bare bones of what Talks does today. Real quick, all it is a tool that can help you test your library and it can handle all the configuration of your testing. Why is that useful? Why do we need some extra stuff? Well, sometimes it's not. But it turns out that in unit testing, it's actually quite useful for a couple reasons. Reason number one, it's useful because it creates a separation between, we'll call it a separation of concerns, between your actual library that you're testing. So for us, it would be our title case library. It's going to separate the actual logic library, which is right here, it's just one module. It separates that from the tests. So this is more along the lines of why did we separate the test directory? Why do we have it out here outside of the title case directory? Why couldn't we just throw it in and then we can import everything? Well, because again, the library is the library. The tests are not part of the library. It's not something that the end user needs. So we're going to separate that out. We do that by, again, removing that directory from the library. But then another step is going to be, well, then the actual testing of it. We're going to separate that out as well. How are we going to do that? Well, I'm going to handle all the dependencies somewhere else. Meaning, if I tell you that in order to run title case, which you see right here, I didn't import anything for title case, which means you don't need anything special to run this module. It's just the Python standard stuff, standard library. But what if I then told you, well, but actually you sort of need to install Pytest too, because to run the unit test, you need Pytest. But now I'm installing Pytest, and Pytest has nothing to do with this module. Me changing the case of a string has nothing to do with Pytest. So why do I need to install Pytest for this library? And the answer is you don't, and you shouldn't. We should separate that out as part of some kind of different process later, right? Somewhere else. And that somewhere else can be Talks. And that will be clear in a minute. The other big thing that it does, the big reason that Talks is useful, again, why learn another tool if you don't have to? The big reason is I can actually test against, and let's take a look here again at the site, I can test against multiple environments all automatically in one go. How? Well, I'll show you in a minute. We're only going to test against Python 3.6 because I'm not going to force you to download other versions of Python. But if I wanted to, if I wrote that title case library and I wanted that library to work not only for people using Python 3, but also for people that wanted to use Python 2.7, then I can just list all the tags I want to test here. I can run the exact same test cases. I don't have to change anything. And what Tox will do is it will test each one in isolation, meaning it will create a virtual environment for each one. It'll say, and we'll see this in a minute, it'll say, all right, create a virtual environment for Python 2.7. Now let's go ahead and install this into that virtual environment. Go ahead and run it and give the result back of those tests. Now create another virtual environment with the Python 3.6 binary. Go ahead and set it up with all this stuff and then run all of our tests against Python 3.6 and then give us the results. So I don't have to write any special tests. I don't have to do any if statements about the versioning. I just give it a list of environments that I promise to support. And every time that I think about making a change to my software, my library, I can run these tests with a single command and it'll run it against 2.7, 3.6, anything else I list up here, all for free automatically. Those are the big two reasons. So again, why is Tox useful? It separates testing from the library and it allows me to test against multiple Python versions by using virtual environments automatically. I don't have to do any of that. Those are the big reasons. If you're not doing one of those two things, you may not need Tox. So let's go ahead and get down to it. I need to do a couple things to use Tox. I need to install it and I need to configure it. Then I need to use it. So step one is install it. Let's go to our command here. Now, this is probably the only time, or at least one of the few times, I'm going to tell you not to use your virtual environment. Notice I don't have any parentheses, framework env over here. If you are in your virtual environment, deactivate it because we're not using it today. Why are we not using it today? Tox handles virtual environments for you. That's one of the things out of the gate that is nice about it. You don't want to be running virtual environments from within virtual environments. It's going to break anyway, but it's just not a good idea because you're not installing things where you think you are. So Tox is going to handle that for us. The only thing is, whatever your base sort of installation is, that's where you're going to install Tox. So I'm just going to pip install Tox. That's it. Let's make sure it works. It's collecting it. We get it. Okay. So great. It looks like we have it. I'm going to clear this here. Let's go ahead and try it. How do I try it? Well, I'm going to type Tox. See what happens. Okay. Good to know. No tox.ini found. Step two is, again, we have to configure it. Let's go back to our file screen here. And I'm just going to go over here because it's less messy. So let's look at our directory structure. What do we have in here? We have a pytest.cache, which is just something that Pytest creates to make it go faster as you run the same thing a bunch of times. We can ignore that. We have our tests, which we separated out from our library title case. We have a README, and we have our setup, which enables us to install this as a library. So I would put my tox.ini in the root directory. So however you want to create it, for those of you that want to heckle me for not using the command line, my excuse is I'm going to use different approaches so that you can see all the different ways that you can create these. So you should be worried. Oh no, I have to learn a new tool. Oh no, I have to learn a new tool and I need to learn a new syntax. Don't be worried. Don't worry. I've got your back. So if we look at the page here, very simple. We're not going to do anything beyond what we already get right here. So you can basically follow along with that and that'll get us where we need to be. So just like Pytest, I give it a tag that says, hey, what follows is a Tox configuration. So there we go. And then I'm going to give a list of environments that I want to test against. Remember, this is not Python. This is a configuration. So the syntax is not actual Python. So that's why I have these variable looking things here. We're not going to use Python 3.7. We're just going to use 3.6. So I know that I have 3.6 installed. If you follow directions, you should have 3.6 installed. If you didn't, then hey man, that's on you. You're going to have to put whatever version you have here and hope it works. No guarantees if you don't follow the packaging. Okay, and the only other thing we need is what should our test environment look like? Meaning when Tox says, okay, think of Tox, by the way, as like a QA person or a scientist. That scientist is going to take the little petri dish that is your library. Our library today is called what? It's called title case. That scientist is going to take that library, he's going to put it under a microscope, and then he's going to take a big binder of tests. Where are those tests? Well, they're right here. We gave him the tests. And he's going to subject our library, title case, to those tests, which are these tests. And he's going to do all of the configuration for us, and he or she, might as well say she, we'll say she. She is going to set up all those tests and set up the testing environment. She's going to perform the tests, and she's going to let us know how it all shook out. How did your library perform against Python 3.6, maybe 2.7, 3.4, whatever. So that's what you should think of Tox as. We can do all the configuration right here. Well, when she creates our virtual environment for Python 3.6 and starts to set it up to perform our test, and it's nice that we get a new virtual environment for free because that's isolation, right? She's testing it in isolation with a brand new virtual environment, which by the way also tests our setup. So what should it look like? We do that by, again, if we look over here, we have something called test env right here. So, all right, let's go ahead and set up our test env. So what does test env look like? Well, in our case, again, looking back at the site, we have two things, deps and commands. What does deps mean? Deps is just what dependencies do you want. So we have deps and commands. Deps is, hey, set up my virtual environment with these dependencies. And commands means here's whatever you need to do to test. In our case, it'll just be Pytest. So what dependencies do I have? Well, here's where things get interesting, and here's where we start to see the benefits of using something like Tox. Again, all of this is going to be in the context of unit testing. This is going to be a different approach if you are performing automation against a web app or a browser automation, stuff like that, functional testing. That's all going to be approached differently. This is specifically if I wrote this code or I am writing unit tests for someone else's code that's on my team, this is when you're going to use this setup. If you're not doing that or don't plan on doing that in the future, please move on. But if you do know that you're going to be working with someone's code and writing tests, which as an automator, you should know how to write unit tests, then please stick around. So this scientist is setting up our special environment just for our test. What does she need? Well, are there any special testing dependencies that we need to run our tests? It turns out yes, there are. We need Pytest, right? Now, you might say, well, like I already installed Pytest. I pip installed Pytest so that we could do this whole thing earlier. Here's where that separation comes in. Remember I said the first important thing about Tox, the first useful thing about Tox, was that it separates testing from the actual library, from the functionality. And one of the ways that we can do that is, I shouldn't have to tell you that if you want to install title case, you're going to need to go ahead and install Pytest as well. Title case has nothing to do with Pytest. If you look here at title case, I don't import anything. It doesn't use any special libraries. It just uses the standard library. So it shouldn't have to know about Pytest. It shouldn't have to know about test at all. It's a self-sustaining library, right? So, well, if title case, if our feature is not worried about, if our library is not worried about tests, who is? The answer is, well, our scientist, our tester, Tox. So I am going to separate out Pytest as a dependency. I'm not going to mention Pytest anywhere in my library at all. I'm not even going to tell you in the README that you need to install Pytest because Tox is going to do it for us. All the testing is going to occur on a virtual environment that Tox is going to create, and I'll show you that in just a minute. So we're going to completely rip out Pytest from our library, and we're going to keep it separated right here. So what am I trying to say? I'm trying to say that any dependencies that are just involved in the testing of your library, the testing of your code, goes right here. We're not going to put your code dependencies here. If your code needs Selenium or your code needs, requests library, something that you need to pip install, that's not what this is for. This is just for the stuff that you're going to test. So in this way, I can make my library completely ignorant about what test framework I'm using. If I need to change my test framework, let's say I decide to use Nose instead of Pytest, I can change all that here, and my library never changes. I don't have to change any code. So I think I've beaten that dead horse enough. If we look back at the site, commands. What are commands? Literally anything that you would do to run the tests. This is basically just going to try and run command line stuff. So if you're on Unix type systems like Linux or like Mac, you can do shell commands. If you're on a Windows system, you're going to want to use Windows commands. We're going to be portable, so everything we're going to do should operate on either. And we only have one command, and that command is, I want you to run Pytest. So that's it. That's the Tox configuration. We said, hey, here's the environments I want to run it against. Hey, here's the dependencies that my tests have. Again, not the dependencies that my library has. These are the dependencies that my tests have. My tests have one dependency right now. That is Pytest. My commands are just going to be, just like we would type it in the command line, just run Pytest. Okay, let's see what happens. I'm going to save it. How do I run it? Well, I run it by typing Tox. Okay, it's creating a virtual environment. How can I tell? Real quick, I'm going to pop on over. Here we go. It created a .tox directory. Under there, they created a virtual environment called Py36. And just like your virtual environment on your local system, mine's going to be on Windows. So you're going to see a bunch of Windows stuff, including the scripts directory. Under there, here's my activate stuff, just like you would see it in your virtual environment as if you created it yourself. If you're on a Mac or on a Linux box, you would see, a bin directory, which would have your activate script and your Python binaries. So none of this should be crazy to you if you understand virtual environments. But more importantly, it created that virtual environment and it set it up. So let me prove that to you real quickly. Before we care about what happened, so if we look at what happened, it blew up, but we expected that. We're going to go into that in a minute. Let's look at what happened. Let's go into our Tox directory. Okay, let's go into our virtual environment. Let's go into our scripts. You don't have to do this. You can just watch me. And let's run the activate.bat, which you'll see, whoops, right here, just like we normally do. If you're on a Mac, obviously this would just be source activate. Okay, wow, I'm inside my Tox virtual environment. Crazy, right? We're in the matrix. Now let's do a pip list. All right, here's what a fresh Tox installed virtual environment looks like. There's two things we're going to look at here. One, it installed our library. Two, it installed our dependencies. How did it know to install our dependency? Well, we told it to, right here. So if I were to put anything else in here as another dependency, it would show up here as well. So that's pretty nice, right? I just gave the scientist kind of a test binder that says, here's all your dependencies, here's all your tests. And then the scientist went, created me a nice, isolated, new, fresh virtual environment, and it put my library, my little Petri dish library into that virtual environment. Just think of it like in a science lab. You've got a nice, isolated little see-through cube, right? We're going to look at the specimen and see what it does. And we went ahead and let's pretend we were looking at, I don't know, like a beetle. So we got a beetle, we're going to put it in this nice, isolated environment. We're like, well, what does a beetle need in order to do what beetles do? Maybe the answer is it needs some grass. It needs, I don't know, a twig. So that would be like our dependencies, right? We say, well, beetle needs to have twig, needs to have grass. So we set up that environment, that brand new little see-through box. We put some twigs in there, we put some grass in there. And then we say, all right, now it's time to observe that beetle and see if the beetle does what we expect it to do. Our beetle is called title case. And we want to set up, here we go. We want to set up our environment so that it can thrive. And the way we do that is we go ahead, we install Pytest, and we let it go. And by the way, when it installs our title case, if there were dependencies, then we would have set it up so that Tox would indeed install those dependencies automatically as well. So that would be the grass and the twig and all that stuff. Moving on. So it blew up, right? Let's go back to where we need to be. Boom, boom, boom. All right, let's run it one more time just to see what happened. It's going to be much quicker this time because we don't have to create .tox. We don't have to create Py36 virtual environment. It's already there. It's going to reuse it. So it failed. Why did it fail? Well, let's start troubleshooting here. If something fails with Pytest, first place we need to look is up here. Okay, is the version correct? Yes, we expect that. Looks like we have Pytest. That's good. Let's look at the root directory. Okay, that is indeed my root directory. That looks good. Let's look at the ini file. Ooh, okay, no ini file. That's no good. So remember, in order for it to find any tests, we're going to have to have our patterns somewhere. Previously, where did we put those patterns? We put them in pytest.ini. But since our scientist is going to handle all the testing for us, we're not going to have a bunch of scattered binders all around the laboratory, right? We're just going to have one binder called Tox, and in that binder is going to be all the configuration. So what does that mean? It means that all the stuff that I initially had in my pytest.ini, I can actually put into my tox.ini. So this might feel a little weird. Hold on, I had a pytest.ini, but you're telling me just to put that into tox.ini. Tox is built to read Pytest. It understands how Pytest works, so you can actually feed it the same things you would feed to a pytest.ini, and Tox will look at it and say, oh, he's about to give me some Pytest commands, so it will go ahead and funnel it all through to Pytest, and it'll all work just fine. So this is a nice convenient thing about Tox, is that it will handle your Pytest configuration for you, but we still have to go ahead and give it those. So let's go ahead and write that out a billion times. You can just copy and paste it if you have your pytest.ini. I'm just going to write it out for the practice. So Python files, Python functions, Python classes. Okay, so I'm going to save it, and just to see if it works, I'm going to try it again. Let's clear this out. I'll type Tox. Okay. All right. So what happened? Well, it picked something up here. Let's take a look. Good. Python version. Pytest version's good. My root directory is still good. And for my ini file, tox.ini. It's almost like Pytest knows how to read the tox.ini file. And indeed it does. So great. We ran our test. It passed. We now have, we're basically done. Like we're running our unit test. Why are we done? What happened here? Well, it said basically, okay, you want to test, you have a library called title case IC, and you would like to test it in Python 3.6. So I'm going to create you a virtual environment called Python, Py3.6, Python 3.6, and I'm going to give it the dependencies that you wanted, which is just Pytest, and I'm going to install your library in it, which is, again, right here. We saw that earlier when I showed you the contents of that virtual environment that it created. Right here, we see, here's Pytest, there's our library. So it did it, and then we gave it the Pytest stuff so it could find the patterns that we wanted it to find, which in this case is, again, the title, blah, 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 tests. We did test underscore and then some stuff. So this should be found. It's a valid test that our pattern should find. And lo and behold, all we had to do was type tox, and forevermore, it runs our unit tests, and we're all happy. So that's it. That's how you use tox at the most basic level to run unit tests. You can essentially say, well, I have I'm going to throw this tox.ini file into my project. I'm going to configure it the way that I want. And then I'm just going to type tox and let it, or I'm going to have my Jenkins or whatever continuous integration tool that I want to use. I can just have it run tox, like install tox, run tox. Tox is going to do all of the virtual environment installation by itself. It will install all the dependencies of title case as long as we built it correctly. It will install all the dependencies of the tests because we put them right here. And then just with a single command, which is tox, it did everything we wanted to do and then it reported back. That's good. That's handy. That's efficient. That's free. We didn't have to do any other architectural stuff. That's one configuration file. That's very small. One dependency, tox. And that's it. So again, when do we need to use tox? If we are unit testing, this is not, if you're unit testing, then tox can be useful to separate your testing from your actual library logic. And also if you want to test your library against, make sure it works in multiple Python versions. Those are some situations where tox can be very useful. There are many others, but that's outside the scope of today. So if you have any questions, please let me know. But feel free to play around with tox. It's a fantastic tool. One other thing I will say is right now when we type tox and it looks for these tests, it's going to look through all of our directories. That's not very efficient. So I will leave you with one final nice little pytest.ini command, and that is test paths. And our test paths are just going to be what? Well, all of our tests should be here. So I'm going to type tests. I'm going to save it. I'm going to type tox one more time and make sure everything looks good. It does. We're all happy. Now it will never waste time looking in these other directories because these other directories will never contain tests. We neatly put all of our tests into one test binder right here, and tox, the awesome QA scientist, is going to subject our library to all these unit tests. And if we change something and it breaks, by the way, let me go ahead and test that theory. If I change something, I don't want to go ahead and have to reinstall it every time. So let me go ahead and change the expected text here. Boom. It breaks automatically. Didn't have to uninstall, reinstall. Tox does it fresh every time in that beautiful isolated virtual environment. So again, I know this is a lot to take in. Just remember tox is a tool to orchestrate your tests. It's great for unit testing because it automatically reinstalls your library every time so you don't have to. And if you want to get into it in more detail, it does a lot more stuff. Please feel free to check it out. I've linked it on the video. Let's move forward.
Okay, so now here's the issue I have with this course. We are just one video away from finishing the course. It's basically a 10-minute video playing it at 2x speed. And he just wrote one unit test on video number 13. Just one unit test. And I consider that the only unit test written because it includes another Python file that is going to be tested. You're not just writing tests to try out tests, you know. I don't know. For a section called writing great test, and you just have one test. And this video was 28 minutes long if you play it at normal speed. And the only thing that I got from of any value there, so to speak, is that tox exists, you know. And there is just one final video I'm going to be watching later, off stream, I think. Yeah, this is going to be a 1 out of yeah, it's awful. No. Yeah, I'm going to request my refund. No, I don't know. The thing is that I wasted a lot of time on this. That's the thing. And that's what I meant by opportunity risk, opportunity cost, because the time that I invested on this course, I could have done anything else. Even if it's not work related or getting into a course or studying anything else, I don't know, I could have gone out and take a coffee break somewhere else, playing video games, sleeping, you know, and doing anything else with my life. And I think that I just wasted too many hours on this. But anyway. Well, thank you for coming in, and if you indeed are. And on the next session, let's try many. I do have a lot of courses that I haven't even started yet, but the ones that I am interested in are related to web development, basically. Well, sort of, because I bought this Pandas course, but I quickly realized that I was not ready for this course because I didn't knew Python enough. So that's why I took the complete Python developer course over here. And now after that, I wanted to have the unit test framework basically in order to just have that, but that was a complete failure, this one. I have another one, I think. Recently enrolled. There we go. So here are the new ones. Automated software testing with Python. I guess this is going to be the next one I'm going to be doing. And let's hope that this is I think this is going to be a better choice because I see a lot of section names that make sense, and there is more content here. And one thing that I like about this is that the videos are very short, are 8 minutes, 2 minutes, 6 minutes, and they get the name of just one thing. And that's the thing that I'm expecting from a course. One video is going to teach me one thing alone. You know, instead of this long videos and I see the teacher rambling about a lot of things, and he just finishes at least one thing in the end. And during the course, I see this attitude of just copy paste this. It doesn't matter that you don't understand this, but it finally it ends up mattering because it matters that you understand that, and he just doesn't explain it because he just stumbled upon things. That's the thing about the Rambler tutorial teacher, is that he's rambling about stuff, and in his mind maybe the subject is very simple because execution is very short for him. But when he gets to the part that he needs to explain stuff, then he just realizes that he cannot really go on with it because he needs to explain something before that, you know. So he stumbles upon it, and that's why we get this 28-minute this 28-minute video before the one that he wants to actually teach, you know. Okay, I'm going to be teaching writing functional tests, but oh my god, I'm going to be using talks, and I just realized that. So I'm going to scramble trying to do a 28-minute video about how to use talks and why to use it. He didn't even explain why should we use it. We are supposed to figure it out by ourselves, I guess. I guess it's going to become very clear on the next video, but I'm going to watch that later, not right now. I actually have a call right now.